Okay, in 8.3 we have a nice short quick section addressing something called trigonometric integrals. This section could be a lot more detailed and involved had I gone into this in a very detailed manner, but there's really only one little skill you need regarding this topic of trigonometric integrals with regard to something we're going to see way later in chapter 10. So just kind of keep that in mind and why this is such a very short lesson. Okay, so trig integrals. You might be thinking, well, we've seen trig integrals, so why is this something that's new? Well, the trig integrals we're going to see here are trig integrals where there is no u substitution that could be used. Of course, we've seen many trig integrals before, from the basic ones to the ones that require a u substitution. But in these particular types of problems in Chapter 8, they're a little more complicated and require a different approach to them. So, how could we evaluate an integral involving sines or cosines to a second power or even a third or a fourth? But we're just going to focus on this second power. You might be thinking we could do a u substitution here. You might be thinking if we just rewrote this integral as sine x squared dx, then that would actually work out. But if we were to do that, it's not going to work out. The only thing we could call u is sine x, and then that would of course mean du is equal to cosine x dx. And the big dilemma with that is that there is no cosine x over here in our problem. And because of that, that u substitution would not work. So we need some sort of other technique to make this problem work out. And the technique here that maybe you can recall back from your pre-cal days is certain trig formulas. And the ones we're thinking of here are the ones that are called either half angle or power reducing formulas. And you can see both of them here. Of course, we're only going to use the sine squared one for this problem. But of course, if you ever saw the cosine squared, you would just use that one in the same manner as you're going to see here. So that's really all there is to it in terms of the trick to making these work. What we want to do is rewrite sine squared as this, using that power reducing half angle formula. After that, it's really just going to come down to your trig skills here, and then I guess integral skills after that to figure out this integral. So what we're going to need to do here is a couple things. The first thing I'm going to do is go ahead and split this into two separate fractions. 1 over 2 minus cosine 2x over 2. The reason we want to do that is because we can take these two integrals separately. And I'm going to already do the first integral on its own. It's really easy to do. The integral of 1/2 would just be 1/2 x. On this other integral, I'm going to rewrite it in a hopefully easier manner to see it. Cosine 2x over 2 can be rewritten as 1/2 cosine 2x. And, of course, because of that, we can pull that 1/2 out to the front of the integral. And now we actually have a fairly easy integral, assuming you can see the approach to it. Since we don't have a plane x on the inside of cosine, we're going to have to call that u. Du would be equal to 2 dx, and of course, since we don't see a 2 in our problem, we see a half in front of the integral, but we don't see a 2, we're going to go ahead and move over that 2 as a half. So wherever we see a dx, we're going to replace it with a 1/2 du. And sure enough, that's really all it takes to make this problem work out. This 1/2, of course, is this 1/2. This 1/2 came from our u box over here. And then of course the integral of cosine is sine, 2x, and then again, don't forget the plus c. After that, we can just clean this up a little. The 1/2 times the 1/2 in front of the sign can of course be rewritten as just 1/4. So the final answer would be 1/2 x minus 1/4 sine 2x plus c. So really not a big deal. We could have easily have done these problems back in chapters 4 or 5. It's just these are a little more advanced kind of integral techniques, and especially since you need these power reducing or half angle formulas, so that's kind of why we're seeing them now. But just take note, this is really not a technique we're going to use here in chapter 8. It's just it's being presented here so that when we need it way later in chapter 10, we can kind of refer back to this. In this last example, I just kind of want to do one that we could have done before 8.3, just to make sure you're kind of seeing the contrast between these two problems. The reason we couldn't do this first example with a basic u substitution was because we didn't see an extra cosine in our integral because of the du. In this problem, we do see an extra cosine. So the very first thing we're going to do, and even if you didn't realize this whole u substitution thing, I hope the first thing you would have done in a problem like this is rewrite those trig powers with parentheses, then the power. Because then it gets a little bit easier to see that we don't have a plain x to a power. We have stuff, which is sine x to a power, and of course we can't integrate that. And I'm even ignoring the cosine x dx as I'm thinking about that. So by virtue of that, again, we're going to have to call u sine x, which then means du is equal to cosine x dx. And again, you can appreciate if for some reason that cosine x dx wasn't there, and it was just sine x cubed, then we'd be maybe in a little bit of trouble in terms of the way we'd need to approach this problem. But luckily, we don't have that dilemma. We do see a cosine x dx in our problem. We see a cosine x dx in our problem, so we can make this one big u substitution. Sine x becomes u, so it's u cubed. Cosine x dx becomes just du, and this is a nice, very straightforward integral. We'll get u to the 4th over 4 plus c, or when we plug the u back in of sine, we'll get sine x to the 4th power all over 4 plus c.